Hello everyone, my name is Vibin Abram and in today's video we will talk about EMF, terminal voltage and internal resistance. So I will divide this topic into 5 different subtopics. Now what are they? We will talk about, firstly we'll talk about cell. Now what is a cell? We'll talk about what is EMF of a cell. Now EMF is a technical term which is used for cell. We'll try to find out what is EMF of a cell. We'll try to find out what is the terminal voltage and the difference between terminal voltage and EMF of a cell. Finally, we'll talk about internal resistance of a cell. Does the cell provide some kind of resistance to the flow of electrons? We'll try to find that out. And finally, we will try to find out relation between EMF, terminal voltage and internal resistance. So let's get started. Okay, let's start with our first topic, that is cell. Now cell is something which is very common to all of us. Every day we use cell. We use cell to power up our TV remotes, we use cell to power up our wristwatch and whatnot. Now we all know this is the symbol of a cell. We have one big line, we have one small line. The big line is positive terminal and the small line is known as your negative terminal, right? And in this picture also something which is bulging out, that is your positive terminal and this is your negative terminal. Now how we define cell? Now according to the most famous definition, the cell is defined as a single power generating unit that tends to store chemical energy and convert them into electrical energy. So your cell is basically a power generating unit, single unit. You have to understand it is a power generating single unit which stores your chemical energy and convert them into electrical energy. Now from where is this chemical energy coming from? Now you have to understand, inside this cell you have some chemical reactions that are going on. Now these chemical reactions are exothermic in nature. So as they are exothermic in nature, what is going to happen? They will release chemical energy. Now the cell actually stores those chemical energy and then convert them into electrical energy for our use. I hope that is understandable. So what is a cell? Cell is a single power generating unit which stores your chemical energy and converts them into electrical energy for our use, right? Okay, I'm sure you must have heard one more term, that is battery. Now what is battery and what is the difference between your battery and cell? Now battery, I'm sure you must have seen this battery. This is a battery of a car, right? It's a car battery, right? All right, now battery does the same thing. The only difference is battery does it in a higher scale, right? Now why it is able to do it in a higher scale is that because battery is a combination of your cells. It's a series combination of more than 2 or 3 cells, right? So the work of battery is same. The difference is that it can do it in a higher scale. Now why it can do it? Because it is basically a series combination of your single power generating cells, right? Okay, so the difference here is for cell you will be getting a low potential difference across its terminal. On the other hand, for a battery you will get a higher potential difference across its terminal, right? That is the only difference. So cell is a single power generating unit. On the other hand, battery is the series combination of more than 2 or 3 cells. I hope that's understandable, right? Okay, now let's try to find out what will happen if I connect this cell across a circuit. Obviously, I'm sure you must have guessed it. What is going to happen? Yes, from the positive terminal current will flow and it will light up the bulb. Is that a yes or no? It will light up the bulb. Now from this diagram, many people can assume that this cell is responsible for the current, and that is very true. That is very true. But you have to understand, it does not mean this cell is actually generating electrons to move. That is not cell doing. You have to understand. Now I will discuss here 2 very important functions of cell which will clear your confusion around the cell. Cell does not generate electrons. Now this is something which you have to understand. Cell does not generate electrons. It does not make electrons. It do make electrons to move, but it does not generate electrons. This is something which you have to understand. So So I'm sure you must have seen, you must be knowing that if the current is flowing in that direction, that means your electrons are flowing in opposite direction. Yes or no? The electrons are flowing in opposite direction. Yes or no? I hope you guys can understand that. Right now, the electrons are already there in the wire. There are a lot of electrons in the wire, in the circuit, right? So there are a lot of electrons already here, right? So electrons are there everywhere. The work of the cell is to maintain a potential difference across its terminal. So when the cell maintains a potential difference, let's say here it is 10 volt, here it is 0 volt. So this, because of this potential difference, what happens? The electrons are forced to move. The electrons are forced to move from higher potential to lower potential, right? So that is the thing. So what the cell do here? Cell creates a potential difference across its terminal. Now because of that potential difference, what happens? Electrons are forced to move. That is the first thing that cell do. Second thing the cell do is cell gives energy to your electrons. Now let's say the electrons are moving like that, right? And in the opposite direction the current are flowing. So as the cell move, right, as the electron move, you have to understand these electrons are right now having some energy. So as it comes near the bulb, it spend that energy and then comes back to the cell and takes the energy and then again go back. So this process continue. So there are two things that cell do. Number one, it maintains a potential difference across a terminal, right? So across the terminals, it maintains a potential difference, right? So because of that potential difference, what happened? The electrons are forced to move. That is the first thing that it do. Second thing, it gives energy. It gives energy to that electron, and that electron spend it on any kind of electrical device which is connected to the circuit, right? For example, in this particular case, what is going to happen? The energy is given to the bulb, and as the energy is given to the bulb, what is going to happen? The bulb will glow. Yes or no? I hope you guys can understand that, right? Two functions. First of all, what is a cell? Cell is a, it's a single power generating unit which convert your chemical energy into electrical energy. Now if you connect your cell across a circuit, what is going to happen? Cell maintains a stable, or I should say a constant potential difference across the terminals, right? Because of which, what is going to happen? Electrons are going to move. And secondly, cell provides energy to the electron so that it can spend it on the different electrical element which are connected with the circuit. I hope you guys can understand that, right? Okay, let's move forward then, if that is understood. Okay, so there are two things. It provides energy to the electrical device which are connected to it. Yes, it maintains a potential difference across terminal which forces the electron to move, and hence the current. I hope that is understandable, right? Okay, let's move forward. The second topic, what is EMF of a cell? Okay, now this will be very strange, but believe me, this is the truth. So EMF is actually a number which is written on the cell. So it is the number which is written on the cell or a battery. If I zoom this picture, you guys can see, if I zoom this cell, you guys can see it is written 1.5 volt. This 1.5 volt is actually the EMF of the cell. So EMF of the cell is actually written on the cell itself, right? It is written by the manufacturer, right? So that is what the EMF of a cell is, right? Okay, so let's try to understand what is this. It is first of all represented by the symbol E, right? EMF stands for electromotive force. Now this is where people become confused, right? Why? Because the full form is electromotive force. So it's basically a force by name, but it is written 1.5 volt, right? It is written 1.5 volt. Now, volt is not the unit of force. Is that a yes or no? Unit of force is Newton, right? Right. But here it is written 1.5 volt, and I just said that 1.5 volt is the EMF of the cell. Now, here in the name it is written it's a force, right? So that is the thing. It is not a force, it is a measure of energy, right? That is 1.5 joules per coulomb. Now you have to understand, let me just very vaguely make you guys understand. If there is an electron which is having a charge of 1 coulomb, and if it passes through this particular cell, right, from your positive terminal to negative terminal, then what is going to happen? This electron will gain an energy of 1.5 joule, right? This electron will gain an energy of 1.5. That is what it is telling us, right? If this electron is going to travel this particular cell, then it will gain an energy of 1.5 joule. That is what it actually trying to, but that is what it actually telling us. That is the information that it is telling us, right? I hope you guys can understand that, right? So it is the potential difference across the terminals of the cell when no current is drawn from it. Yes. So basically, when you buy your cell, so it is written 1.5 volt and you have not connected it with any kind of circuit, then the potential difference across this terminal is what is termed as your EMF of that cell. I hope you guys can understand, right? So when it is not connected with any circuit, the number which is written on the cell, right, it is what the EMF of a cell is, right? Okay, and obviously the units are volt. It is not a force, although it is written electromotive force, but it is not a force, it is a measure of energy, right? So if an electron is traveled, which is like, let's assume it's having some 1 coulomb charge, right? So if it is traveled from here to here, then it will gain 1.5 joule energy. This is what it is telling us, right? I hope you guys can understand that, right? Okay, great. Now if that is true, let's try to understand what is terminal voltage and internal resistance of a cell. Now right now we know what is a cell, we know what is a battery, we know what is EMF of a cell. Now you guys can see it is written 1.5 volt. It is written 1.5 volt, right? It is connected to a battery. Obviously what is going to happen, we all know what is going to happen. The current will flow from the positive terminal and it will come back here, right? And in the process, what is going to happen? Your bulb will start glowing. Is that a yes or no, right? Okay, now let's try to find out what actually happens here, right? Now obviously if if your current is flowing like that, then what is going to happen to your electrons? Electrons will be flowing in the opposite direction, right? Can you guys see that? Electrons will be flowing in opposite direction of that of your current. Yes or no? They will be flowing in the opposite direction of that of your current, right? Is that a yes or no, right? Okay, now when, let's say, the electron is here, right? Let's say electron is here, and when it try to reach the positive terminal, now you have to understand, electron being negatively charged, it is attracted towards this positive terminal. It will be attracted towards that positive terminal. Now here's where your battery comes into action. Now what battery does is it pushes your electron against your electrostatic attraction. Normally electron being your negatively charged, it should be attracted to your positively charged, your positively charged electrode, but here's where battery comes, here's where battery do its magic. Now what battery do is it pushes this electron against this electrostatic, repulsion, against this electrostatic attraction, and it makes sure that this charge reaches here on the other side, right? So again I'm telling you, so this electron which is being negatively charged, its natural tendency is going to attract this positive terminal, yes or no? Now what this battery do is it makes sure this electron reaches all the way to the other side, right? Now in this process, so basically you have to understand, in this process of movement of electrons inside the cell, this movement is against the electrostatic forces. You have to understand that electron is moving against electrostatic forces, and hence it gains some energy. Normally the things which is happening inside, normally we call it because of the battery mechanism this happened, right? So because of the battery mechanism, what is going to, this electron is pushed to the other side. Despite the strong electrostatic attraction and repulsion, it is pushed on the other side, and in doing so, what is going to happen? This electron gains some energy, and with that gained energy, it goes to the circuit, right? It dissipate all of its energy in glowing this bulb, and it comes back here again. What is going to happen? This electron is reaching here. This cell makes sure that it can reach to the other side. Again, it gains some energy, and again it will go and spend all the energy and then come back, and this process continues, right? So as these electrons are moving, the current is there, the bulb will glow, right? So normally we can understand when this, when this travels from here to here, what is going to happen. Normal case is, obviously, we can assume that this is a, let's assume this is a 1 coulomb charge, right? It has traveled from here to here, right? The normal understanding is that it will gain some energy, right? Now what is that energy? That energy must be the EMF, which is like written here, right? So let's say if it is a 1 coulomb charge, the energy it should gain is 1.5 joule. Yes or no? This much energy it should gain, right? But the problem is that that is not the case. That is not the case. This much energy is not gained by this electron. Now what is the problem here? The problem here is that as this electron moves from here to here, it is not so smooth movement. Now why it is not so smooth movement? Because you have to understand there are lots and lots of particles inside. You can say there are lots of mediums inside. Now these mediums make it really hard for this electron to move. So what's going to happen? This electron which wants to move from here to here, it collides with the different medium materials and then it comes back, right? Now you have to understand, as it is facing some difficulty, right? So in that difficulty, what is going to happen? This electron gives some of its energy to the neighboring charge particle, right? This electron will give some of its energy to its neighboring charge particle, and as these charge particles take that energy, it starts vibrating at a very high speed, right? So there are like lot of chemical or ions that is present inside the cell. So as the cell is moving inside, right? So this cell tend to give some of its energy here. Now because of that, what happens? This battery heats up, or this cell heats up, right? Because of that extra energy, you must have seen after some time your cell started getting heated up, right? Now what is going to happen? It will start releasing some energy. Now you have to understand, some of the energy is released in the form of heat, right? That is the main problem here, right? So let's say that the electron has traveled all the way through, right? So but instead of 1.5 joule, let's say some of its energy is being lost in the form of heat, and let's say some 0.2 volt of energy or 0.2 joule of energy is being lost here, right? Okay, so what will be the energy of the electron which is like over here? What will be the energy? Now the energy will be 1.5 minus 0.2, or you can say simply energy will be 1.3 joule. Yes or no? Or in another word, we can say this electron will be having 1.3 joule per coulomb. That is, if it is a 1 coulomb electron, it will gain 1.3 joule of energy, right? So this is what we call as the terminal voltage, right? Normally it is written 1.5 volt is the potential difference across it when you are not taking any charge from it, or you are not taking any current from it. But the moment an electron travels from here to here, what is going to happen? It gives some of its energy here and there inside that particle, right? And as the particle takes energy, the entire system becomes heat up, and some of the heat are released in the form, some of the energy is released in the form of heat. And because of that, you must have seen, if you connect if you connect a voltmeter across it, you will never get 1.5 volt. You will always get less than 1.5 volt. You will be getting 1.3 or sometimes 1.2 depending upon the conditions of the battery. Is that a yes or no? So what is your terminal voltage? Terminal voltage is, you have to understand, terminal voltage is the potential difference across your cell or battery when some current is drawn from it, right? So what is your EMF? EMF is the potential difference across the battery when there is no current drawn from it. What is your terminal voltage? It is the potential difference across, again it's a potential difference, but it's across the battery when some current is drawn from it, right? So it's pretty simple. 1.5 must be the answer, but you are getting 1.3. Why? Because some of it is lost in the form of heat. Is that a yes or no? Right? Okay, now internal resistance. Now can you guys understand, as this electron was flowing here, there were resistance by these material of battery. Because of the material of battery, there was some resistance in the flow of electron. Right? Because of that resistance, what happened? The energy is released in the form of heat, right? So that resistance is what we call as the internal resistance of a battery. In normal cases, we represent the internal resistance like this. For example, if this is the cell, it is represented outside with this symbol R, and this cell which is having some EMF E, right? So although the internal resistance is inside, but we represent the internal resistance outside whenever we are drawing the structure of the cell. Is that a yes or no? I hope you guys can understand, right? So we can simply say the internal resistance, it is the hindrance in the flow of charges inside the cell or the battery by the material of the battery. Secondly, what is your terminal voltage? The potential difference across the terminals of the cell or the battery when the current is drawn from it. I hope you guys can understand that, right? Now, if we try to find out the relationship between your EMF, okay, let me just tell you, your internal resistance is represented by small r and your terminal voltage is represented by capital V, and also we know your EMF is represented by E symbol. Yes or no? Now let me try to find a relation between your terminal voltage, EMF and internal resistance. Now you can simply see 1.5 joule was the energy which 1 coulomb charge must have gained when it was traveling from one end of the cell to the another end of the cell. Yes or no? So can I write it like that? Just you have to be very careful here, right? So 1.5 joule was the energy which was supposed to happen, or I can simply say 1.5 volt was the voltage across your, battery, but it is being reduced by 0.2 because that much, volt has been, gone in the form of heat, and this is equal to your 1.3 volt, which is the terminal voltage. So can I say, we all know this is voltage, and this is also voltage. So can I say this is my terminal voltage V, right, which is like the potential difference across the battery or the cell when the current is drawn from it. And what is this 1.5 volt? Is it the EMF of the cell, right? Can I say like that? So this is my EMF, that is your 1.5 volt minus, okay, this is also let me just say, this is also some potential difference, right? Now this is because of the internal resistance. So can I say this, there is some internal resistance R over here. So can I say this is some I times of R as the potential which is being lost in the form of heat? Yes or no? So the relationship between your EMF, your terminal voltage and your internal resistance is given as your terminal voltage is actually equals to EMF minus of I times of R, right? I hope you guys can understand. It's pretty simple. Let's say if you have a cell which is having some internal resistance, which is having some EMF E, which is connected to an external resistor R, right? So you can simply say this V or the terminal voltage V is given as simple EMF minus I times of R. I hope you guys can understand that. Yes, I hope that is understandable to everyone. If you have any doubt, you can ask me in the comment section. That's all for today. Thank you and have a nice day.